Hey friends, we're still in chapter 3 and we're looking at linear functions, but in section 3.2, we're going to look at solving linear equations by graphing. Here's our vocabulary. As we look at a linear function is a function whose graph is a line. This is very similar to another definition that we had of a linear equation. Equation and functions aren't necessarily the same. I'll give a prize to the person that could figure out the difference between a linear function and a linear equation. What's one difference between the two? But they're, for the most part, they're very much the same. This concept of parent function is a little bit hard to explain without a lot more algebra knowledge and graphing knowledge. But basically, the idea of parent function says that there's one function that kind of typifies a whole group of other functions in terms of its graph and form. So when we talk about linear functions, we can talk about the graph of a linear function, of the linear function that's, let's say, f of x is equal to x. And we know that just means y is equal to x. So this is kind of like a basic line graph. It goes through the origin, it's basic, and all other functional lines or linear functions can be written as an adjustment of this function here. So that's really what the concept of parent function is. And you've got one for parabolas and other different shapes, not just straight lines. A family of graphs is a group of graphs with similar characteristics. Pretty straightforward there. So if I'm talking about a whole bunch of lines, that's all a family of graphs, and I'm talking about a whole bunch of parabolas. And if some of you don't know what a parabola is, it's kind of a beautiful U-shape thingy like that, and we get it by graphing y equals x squared, or in its form as a function, f of x equals x squared. So this would be considered a parent function, and then all graphs that look kind of sort of like this, that have an equation with x squared, that would be a family of graphs because they have similar qualities. And finally, this last one, root and zeros. The concept of root and zeros is one that I usually see in Algebra 2, but I like that our text introduces us to it because I think that it's a good idea to get started with certain vocabulary. So roots and zeros refers to, roots or zeros I should say, refers to the value of x that makes a function equal to 0. It's the value of x that makes a function equal to 0. So if I had the function f of x is equal to x minus 5, what would make f of x equal 0? And I know some of you rather see it like this. So if I had y equals x minus 5, what would make y equal 0? And I'm sure most of you or everybody can see that if x is equal to 5, this whole thing would go kaplooey. Y would equal 0. And indeed, 5 is a 0 of the function f of x. F of x is equal to x minus 5. With our first example, we are given two different methods of solving an equation. So we're going to solve each equation here. The first one we'll solve in one method, and the second one we'll solve in another. I know that you guys can solve these without even thinking, barely, because we've done this 1,000 times. However, let's just follow through with the first example, and we'll see how it relates to the second example. If you notice part A is set equal to 0. So really, when we solve for x, we are finding a 0 of the related function f of x is equal to 1 over 3x minus 2. And I'm just going to say that for now, and then we'll look at how that relates when we look at this next equation. So as I look at this guy over here, what I'm basically going to do is solve like I would any other equation. I've got 0 is equal to 1/3 x minus 2, as we like to have constants on one side and x terms on the other, so I'm going to add 2 to both sides. And when I do that, I'm left with 2 is equal to 1/3 x. How do we undo this multiplication? We're going to multiply by the reciprocal. So we multiply by the reciprocal of that fraction, and we can all see that when x is alone and isolated, we know that x is equal to 6. And that's perfectly fine. That's a very effective way of solving an equation. In fact, that's the most direct way. I'm going to show you an indirect way of solving this next equation. And really the reason why we're doing it this way is to emphasize the concept of roots, to emphasize the concept of zeros of a function of an equation. So I'm going to actually erase this. So with this second method, what we're going to do is graph our solution. We're going to find our solution by graphing. So we're going to find the zero, or the solution, or the root to this equation by graphing. And I'll show you what we'll do. First, we're going to alter this. Let me use something other than that. We're going to alter this by rewriting 3x plus 1 equals negative 2. And we're going to put everything over to one side. So we have 3x plus 3 equals 0. Notice what I did. I added 2 to both sides in order to get this whole thing equal to 0. And now this is the equation that we want to solve. But what I'm going to do is I'm going to write the related function. So basically, after I solve for 0, I'm going to write this as 3x plus 3 is equal to f of x. Or of course, you know I can write that as 3x plus 3 is equal to y. I'm going to turn it around and do that. So y is equal to 3x plus 3. What I now do is I'm going to go and graph this function. In the last section, we talked about graphing functions in a number of ways. We used a table and we used, what were they called? Intercepts, x and y intercepts. And to calculate, and I think we're going to use x and y intercepts, I think it just makes sense. To calculate the x-intercept, we're going to throw a 0 in for y, and then to calculate the y-intercept, we'll throw a 0 in for x. So let's do the y-intercept first. If I put 0 in for x, I have y equals, I'll do this over here, y is equal to 3 times 0 plus 3, and therefore y is equal to 3. So I know that 3 on the y-axis is a point on my graph. So that's me indicating that. And then now if I do, I could either find the x-intercept, or I can actually go ahead and plot some points. It doesn't really matter. I'm going to do the x-intercept, which is going to seem baffling a little bit, but when I do this, I get that 0 is equal to 3x plus 3. If I move my 3 over to the other side, I'm going to get negative 3 is equal to 3x. And so I'm going to put a line over here. Negative 3 is equal to 3x. And then quickly solving, I get that x is equal to negative 1. So then when I do that, I come back here and I have negative 1. And then so I've got that there. And then I'm going to draw a line through all of that. Let's see if I can get a line to come up. That's not that good. Let's try again. There we go. That looks a little better. All right, good. So I've got that line and I am done, but I haven't actually solved the question. The question was, what x value is going to satisfy this situation? What the text wants to point out to you is that if you graph the related equation as we have, what you get is an equation that has a 0 at the answer to our original problem. So the answer is this guy here. What value is going to satisfy this equation if x is equal to negative 1? So the solution, or the root, is actually negative 1. I know it's cumbersome, I know it's tiresome, but it's going to emphasize a really good point. Let's try a couple other examples. In example 2, what we're going to look at is solving equations with no solution. You guys remember this before. We looked at problems like this where it looks almost identical on both sides, but then there's one thing that's off, and clearly there's no solution. Well, let's process this in the sense of what we just looked at in terms of looking at the graph of the related function. So what we do is we bring everything over to one side, and so in this case, I can subtract 3x from this side and subtract 3x from this side, and I see it. The x's have gone, and then the x terms have gone rather, and I have 7 is equal to plus 1 or positive 1. I'm going to subtract 1 on both sides, and then I end up with 6, right, is equal to 0. And remember what we said we were going to do? We were going to write the related function, so replacing the 0 with y or f of x. So if I say this is f of x is equal to 6, or y is equal to 6. Now we already know that this has no solution. In fact, it says it in the title. But let's think about how this plays out in terms of graphing. What does it look like? What does an equation look like when there's no solution and we graph it? Does anybody remember how to, I put that line there, does anybody remember how to graph a y equals, we call this actually a constant function. Anybody remember how to graph this guy? We go to to the y-axis and we recognize that obviously that must be the y-intercept, correct? So it's 1, 2, 3, 4, 5, 6. And what we do next is we actually graph a horizontal line. And if we think about it, it makes perfect sense because, let's get my horizontal line there. That's not the one. Let's try again. There we go. That's gorgeous. All right, so we get this horizontal line. Why do we get a horizontal line? Because this this function is saying, I don't care what x is, y is going to be 6. Y is going to be 6. That's what this is saying right here. Oh, let me try again. That's what this guy is saying right here. I don't care what x is. X doesn't even exist in my world. I'm just going to be 6. So it's this beautiful horizontal line. But check this out. Where is the x-intercept? There isn't one. There's no x value that is, there's no x value when y is equal to 0. And so what that is emphasizing here is that there is no root to this equation. And so that's why when we see this equation, it has no answer or no solution, and it's emphasized by the related function because there is no x-intercept. Let's look at this next one. Okay, so 2x minus 4 is equal to 2x minus 6. Clearly we know this isn't true. Let's get rid of the 4 just to move everything onto one side. And when I do that, that's gone, and I'm left with 2x is equal to 2x minus 2. And then the final thing we're going to do is get rid of the 2x on this side, and then we see we're left with 0 is equal to negative 2. The related function is f of x is equal to negative 2, and of course we sometimes write that as y is equal to negative 2. And what does that graph look like? Well, you guys are now all properly a part of the initiated. You know that this is just a horizontal line at negative 2, and I'll emphasize that that's negative 2. And so because of that, there's no x-intercept. X-intercept would be our 0 or our root when we look at the related function, and clearly here we don't have that, so we are done. There's no solution, and we see it here in our graph. All right, guys, we've come to the end of our video. Let's make sure we get this assignment done. It's not too long. It's just one page, 164, 19 through 35 odd, and then 38 through 43. Have a good one.